about cloud native and container support in ONAP. This talk is in collaboration with Srini Adapalli, who is an architect at Intel, and Bin Hu, who's an architect at AT&T. And unfortunately, neither of them could make it here, so you have to do with me. So if you have any questions which I'm not able to answer, I can always bring them back to them, and then we can get them answered. Okay, so let's start. So I'm going to briefly talk about ONAP in the beginning, and then I'm going to talk about some of the trends in the industry around edge computing, network automation, and microservices. And then I'm going to talk about what are the needs and opportunities that provide us and how we are solving it in the open source community. And in the end, there will be summary and some call to action. Okay, so I'll start with a little overview on ONAP. I don't know how many people here are familiar with it, but ONAP stands for Open Networking Automation Platform. And this is a project which is started by AT&T and merger of OpenO with AT&T's eCom project beginning of last year. This project provides like a platform for creating, designing, orchestrating, and managing VNFs and the full life cycle of a VNF. It has closed loop automation where if there's something goes wrong with the VNF, it can automatically restart the VNF and so on. And there have already been 2 releases of this project. The Beijing release was the second release, which happened in May this year. So this is a very high-level architecture for the project. It is a very busy slide, and it's a big project. So on the right side, there are the design tools that are available for the VNF vendors to create their VNFs, design them, and then those VNFs are onboarded. And on the left, you see the runtime components, and these are the components which are actually orchestrating those VNFs, deciding where those VNFs need to be placed, on which clouds they need to be placed. And at the bottom, you see actually the clouds where those VNFs are actually placed. So in the first release of ONAP, all these the components which make up ONAP were also as VMs running on OpenStack. So we had ONAP components running on OpenStack, which were scheduling or which were orchestrating VNFs running on OpenStack at the bottom. In the Beijing release, the ONAP components also were able to run in Kubernetes, but the VNFs still run on OpenStack. So they are still VMs, and that's what we want to change going forward. So I'll just briefly go over what is edge computing, and this is becoming very important for cloud computing these days. So what you see here is what we have typically like these days, like a PC or you have your phone, and you run some apps on it, and that your application might require some support in the cloud, like you're running your Netflix movie, and you might spin up like a VM for that in the cloud. So what you have is a network edge, and you have the core network. So basically your network infrastructure and a cloud at the end. And with this, you can get latency about 100 milliseconds, and which seems to be fine for many enterprise applications and video streaming. But going forward, we'll have use cases like audio, the virtual reality, and live gaming, and so on. So in those cases, we'll have a latency requirement of the order of 20 milliseconds. And for that, the compute has to be nearer to the devices. So as you see in this picture, right, we'll be in the future or like already starting to run some applications right on the network edge. And then there are some network some edge clouds also added, and you run some of the services there to meet those your latency requirements. So it's basically you're trying to optimize the cloud computing systems by performing data processing at the edge of the network. All right, hang on. So another trend which is there in the industry is automation and orchestration around network services. And ONAP is one of those examples. So in the previous slide, we saw that your one application may require you to spin up VMs on multiple locations, right? Like you may need a VM to be spun up on your private cloud and another VM to be spun up in an edge cloud, and they are all provide the same service for the customer. So ONAP is able to handle that kind of services where it is able to decide which part of the service needs to run where, and then do it as a single action. So all these apps that you see are all brought up in ONAP as a single action apps, and it takes care of providing that service end to end, talking to the various VIMs that we have here, right? There's a VIM running on the edge cloud, and there's a VIM running on the private cloud. And it also does our entire lifecycle management of like bringing up these VNFs and tearing it down and healing and migrating, restarting. And like I mentioned, like a closed loop automation, like if there's something, it is able to detect anything wrong in the VM based on the events, and then restart that VM all in an automated manner. And this becomes very relevant when you have like hundreds of thousands of customers having their apps, having services that need to be spun up for them. Okay, so another trend that we are seeing in the networking world is around the microservice architecture. I suppose many of you are familiar with this, but just to quickly go over it. So traditionally, we had monolithic applications where you had like a module at the end, and then you have an external module and some internal modules, and they'll all communicate with each other, and you have one monolithic application. So the problems here that we are familiar with is that if you want to scale it out, you'll have to scale out the whole application. And if there's something wrong with the application, you'll have to bring down the whole application, fix it, and then bring the whole thing up. So what we are seeing now is a move towards, instead of modules, like having services, right? So all these modules that you see here, if you can see okay, that's fine. So if all the internal modules now are converted into internal services on the picture on the right, and these services are basically containers. And as you can see, you can scale up these containers as you want, as needed. And then if you want to replace a container, a service with some other new service which is better, you can replace it. And also, and these services can be in any language, right? There's no language barrier. They don't have to be in the same language, or they can be anything that you want them to be. So we see a big trend in the industry going towards this architecture. And like I mentioned, ONAP itself, the ONAP components itself in the Beijing release are now, there is an implementation with this services model, and it can run on a Kubernetes cluster. Okay, so, but having said that, right, if once you move to this services architecture, it brings its own problems or challenges, and many of them are like, now that you have so many of these services running which are talking to each other over the network, you need some way of finding them, like a discovery, and you also need to do health checks on those and fault tolerance. And you also need to collect some data as to what's happening in the service and so on. So this is like a microservice tax, which every microservice has to implement. So to solve this problem, many open source projects have been coming out in recent months and last year or so. One of them is STIO, and another one is Envoy Proxy. The idea here is that with each service, you will have like a sidecar, and the sidecar will implement all these common functionalities, like the health checks, the discovery, mutual TLS between all these services, and also that's on the data plane side. And on the control side, there's something like STO, which where you can set up your traffic rules and your security rules, and together, like this can take care of all these overhead of microservices, and the programmer or the developers are freed from having to do anything with that, and then they can concentrate on their applications. And for ONAP in the Casablanca, we didn't have this in the Beijing release, but for Casablanca we are we are trying this out and seeing for few of these. We're trying out at a smaller scale, and then we'll take it to the whole ONAP system. Okay, so now we'll talk about like how some of these trends we can see how they apply to how we can use them, right? So so for this is what we already talked about, right? So in ONAP we have we can support like multiple OpenStack installations, right? We can have we support like OpenStack variations like Newton, Okata, and going forward Pike, and also Wind River, Titanium, and VMware VIOS. That is the current support, but it's only VMs. And but like we discussed about the edge clouds, right? So edge clouds are going to run in those locations where it will be compute and memory will not be very will be as good as in a data center, right? So it will be a very constrained environment. So running VMs in that environment will be very costly, and we also will want to have like a lot of density, right? You don't want to run few VMs on machines. So what we are going to do in Casablanca is we are going to add support in ONAP to be able to schedule containers on a Kubernetes deployment. And the trend is like we'll have both VMs and containers together going on for some time. We don't see VMs going away anytime soon. So what we really need is like where we are able to run both of these containers and VMs at the same time. So Vertlet is one project which Mirantis has launched recently, which provides facility for running a VM in a Kubernetes cluster. So we are going to use that project here in ONAP so that we don't have to have like multiple control planes, and we can use the same compute nodes to run both VMs and containers. Okay, so this is the networking aspect of it. So this is the current situation where we have like the ONAP running, and then we have ONAP scheduling these VMs on the site or edge, right, in this case. And these VMs can be on different networks, and they can be connecting to the same network, like different VMs can be talking to each other. Extending that, we want to add containers on the same networks and with the same kind of properties as the VM had. So one of the things about data plane containers are that they need multiple interfaces, and that is currently a drawback of Kubernetes, is that Kubernetes only allows one network per container. But there is work in the Kubernetes community being done to add multi-network support. But on the other side, There are projects in the industry like Multis from Intel, which allows containers to have multiple interfaces and multiple IP addresses. We'll be using Multis project in our in ONAP. So another requirement which data plane containers have is like high packet processing performance. And we'll see in the subsequent slides how we are going to address that also. This is so we are going to do the implementation of this in ONAP in a couple of phases. So ONAP is a 6-month release cadence. So we'll have another release coming out of ONAP in November timeframe. So for that, what we want to achieve is that we are able to support sites that are supported by Kubernetes, like running bare metal containers. So as you see in the picture, so SO is the service orchestration component within ONAP, and VFC is another service orchestration component there. So we will get a request from SO into the multi-cloud project in ONAP. The multi-cloud project is the project which is managing these different OpenStack variations, right? So we have to have, all these variations have some differences, and they are kind of managed by the multi-cloud project. So in the multi-cloud project, we are going to add support for Kubernetes. So we're going to add a Kubernetes plugin over there, and so what you will get from SO is some metadata and some artifacts for Kubernetes containers that need to be run. And for Casablanca, we are only going to be support the YAML files. So we'll get those YAML files from the SO. And the plugin will be the one which will be actually talking to the local Kubernetes deployment, and will deploy these containers on that on the Kubernetes deployment. So for networking, right, for network virtualization, we are going to use OVN, and the reason for that is that it's it's very popular in the industry, and it supports OVS. And with OVS, we get acceleration like OVS TPDK, and we can also do stuff like SFC, as you can program OVS easily using programmable rules. And then, like I mentioned, we are going to use Virtlet for VMs and Dockers for containers. And in this time frame, what we are looking to prove is that we can run like an Edge X Foundry services as containers, which is an IoT infrastructure open source project. So these containers, the Edge X Foundry containers, do not have requirement for multiple interfaces, but we are going to run those as for proving our implementation. And then we also plan to run a DPDK-based router here, which will require multiple network interfaces. So to prove that we can have multiple network interfaces. And then we will ensure that both VMs and containers can exist on same network and work when placed on the same compute node. Okay, so beyond Casablanca, right, we plan to add a lot more to this support. So we are going to add support for Helm-based artifacts, and we are also planning to add support for container as a service and be able to run these containers in IBM, GCP, or AWS clouds, and that will need change to our plugin. Also, we want to add another feature like which is like node feature discovery, which is also a project from Intel in Kubernetes incubation. So basically where you can find out what are the hardware capabilities of the nodes on which are part of your cluster, and then and within ONAP, we have a project called Optimization Framework, which actually takes in all this information in terms of flavors, and then is able to choose what is the best match for your workload, where will the best capabilities, where all the capabilities or the max number of capabilities that you need, which compute node will meet those, and then it will schedule your workloads on that compute node. So we are going to kind of integrate that with the containers in the phase 2. And also, we plan to do integration with C Advisor and Node Exporter, as this is very important in the edge cloud. So these capabilities allow you to get the hardware state of the system, and also like performance counters, and it gets you visibility into what's happening in your containers. And on the edge clouds, it will be very important, as it's a very constrained environment, and we want to know what's going on there. Okay. So in summary, there's like good amount of innovation in cloud native world to develop and simplify security, like we see around microservices architecture and service mesh architecture, and we saw like how we are using those learnings to our data plane, control plane, and management plane workloads. And ONAP team is currently working on the gaps that we discussed, and hopefully in the next release we'll have many of these things figured out, and we can demonstrate something useful and something that can be used. And at the bottom is the link to the page in ONAP, where you can find more information about this project. And if people are interested to contribute, all contributions are welcome. Okay.
Thank you. Ma'am, did you run any performance benchmarks with the 3 kinds of applications, or any kinds of applications like data plane containers, or control plane, or management plane? Like you mentioned some of the things like virtual firewall and router and things like that.
So you mean using containers?
Containers or VMs in this architecture on a platform.
For ONAP, you mean?
Yeah, the ONAP framework you mentioned, and in that there are some containers. If you go back, the networking you may later. Yeah. So you mentioned some of the things like VM, 2 VMs on the side, and then containers in.
No, so this is something we plan to do in the upcoming release. So we have started work on it. Actually, there are 2 projects started. One project is to get the deployment, right? The deployment with Vertlet, Multus, and all these other OVN going. So, and then the other project is what I showed on the Kubernetes plugin. So we have started work on these things, and in the next release by November timeframe, this is what we are going to do.
So one more follow-up question. So for those functionalities, the virtual firewall and router and Edge X, are there any commercial vendors that are porting their applications into this framework, or are you taking just a Linux-based?
So for the EdgeX Foundry services, they are open source and they are available, right? The DPDK-based router, I'm not sure. I can let you know. But those are the 2 things that we are planning. So the virtual firewall, that is a VM, right? So the virtual firewall is a VM which already exists in ONAP. That's not a container. So in this picture, you see like the firewall is a VM, and the router is a container, and EdgeX is container. So yeah, I don't know if there's any commercial, implementations of these available on containers.
Thank
I
you.
can add to that.
Now the questions are piling up. Okay, so hold on. We're going to go here, and then there, and then there. So first here, and when you're done, just put this thing back down. Perfect. Guys are on it. Yes, please. Go ahead.
So there is a project fd.io for vector packet processing. Are you supporting that with this?
Not in this phase, but yeah, maybe in the later phases, right? So we will have no problems integrating with DPDK, right? So
Disclosure, I'm from Cisco, so.
yeah, there is there's no plan right now in phase 1, but going forward, of course, yeah.
Okay, Robert.
Actually, my question got answered.
Oh. Now I'm curious what it was. Dave.
Somebody was asking if there are any commercial products. At Redis Labs, we're actually putting Redis Enterprise and Redis Open Source into the EdgeX Foundry, so that you'll have...
What's that? Can you repeat that?
We are supporting Redis database
Okay.
in EdgeX Foundry.
Okay, great. So yeah, we can.
So there is enterprise support for some of these.
So yeah. Okay, great. Yeah.
On a prior slide, you mentioned the Marantis project,
Right. Wordlet.
Vertlet.
Yeah. That's basically just like a CNI plugin, right? They have a framework where you can plug in anything else other than Docker, right? So this is, you can plug in like a VM, where you can plug in support for VMs.
Do you know, so that's rather than doing KubeVirt,
What's that?
is that an alternative to KubeVirt?
I am not familiar with
Okay,
KubeVirt.
we can talk.
Can you run both containers and virtual machines using
Yeah.
KubeVirt?
exactly.
Okay. Okay. Yeah, that will be good to know.